Okay, so let's look at number 6. Number 6 is the rational function g of x is equal to x squared minus 9 over x squared plus 4x minus 21. To find the x-intercepts, we need to set the function equal to 0. And remember, as we did that before, we kind of did this cross multiply thing. So we really determined that what we were doing is we were just setting the numerator equal to 0. And I want to factor. So I have x minus 3 and x plus 3. Now, I learned in the last problem that I actually might have a hole in the graph, and I want to check for that first. So let's just factor up here, and we'll have x plus 3, x minus 3. In our denominator, we factor that, and we find out it's x minus, let's see, plus 7 and x minus 3. So since I have x minus 3 both in the numerator and the denominator, I actually do have a hole in the graph. And I set that x minus 3 equal to 0, and I solve for that and get 3. So I determine there's a hole in the graph at x equals 3. So now I don't have this situation because that's been taken out. I just have the x plus 3. I solve for that and I get x is equal to negative 3, or x-intercept, or my horizontal intercept, and that is going to be at negative 3, 0. Now, to determine the y-intercept, I looked at that before and said, okay, remember I just put zeros in for x. If I put zeros in for x, I'm going to have, here I put, I'll have 0 squared minus 9 over 0 squared plus 4 times 0 minus 21. So that's just going to be negative 9 over negative 21, which is going to simplify to be 3/7. So I know that I have a y-intercept at 0, 3/7. The other thing I want to determine is my vertical asymptote. Well, my vertical asymptote, I have learned from previously, is where my denominator is equal to 0. So if I look up here, I've already factored my denominator, and the x minus 3 cancels out, so I just have the x plus 7. So if I solve for that, then I get x is equal to negative 7. So I have a vertical asymptote at x is equal to negative 7. Then it asks what happens when x goes to negative infinity and when x goes to positive infinity. This kind of all is negligible when x is really, really big or really, really small. So I basically have just x squared divided by x squared, which is equal to 1. And so what happens is this graph becomes closer and closer to 1 as x gets very large and x gets very small. So this is what I would determine to be my horizontal asymptote. My horizontal asymptote is going to be y is equal to 1. Let's see, I think I have, do I have it graphed over here? I think I already have it graphed. Let's look at the graph. A vertical asymptote over here at x is equal to negative 7. It does also look like I have a horizontal asymptote at y equals 1. and then it crosses the x-axis over here at -3, and if I wanted to find that 0, I could. It also looks like it crosses the y-axis at, somewhere between 0 and 1. And if I wanted to go into second calc, I could find those values as well. To confirm the hole at the graph, I could use my table. So let's do table set at 0 and go up by ones. And I would have an error at 3. And that is what I would expect. I would expect to have a hole in the graph at 3. Okay, so let's look at our last one. Okay, our last graph is, actually it's k of x is equal to 3x squared minus 11x minus 4 all over x squared minus 4. Okay, so it might be the best thing is just to go ahead and factor the numerator and the denominator. And to get the 3x squared, I'm going to go 3x times x. I need to get 11 in the middle. So I'm going to put -4 here and plus 1 here. And I think that will work out. And you can distribute that out and check it if you would like. And on the denominator, I'm going to have x plus 2 and x minus 2. Okay, so here I don't have any holes in my graph, and I can determine the x-intercepts by setting the numerator equal to 0, numerator, since it needs to be factored anyway. So I have 3x plus 1 is equal to 0, and x minus 4 is equal to 0. So here 3x is going to be equal to -1, so x is equal to -1/3. And here x is equal to 4. My x-intercepts are going to be -1/3, 0, and 4, 0. To find the y-intercept, I am going to plug 0 in for x. And if I just look up here and in my mind say, okay, this is going to be 0, this is going to be 0, this is going to be 0. So basically, I'm going to have -4 over 4 or just 1. So my y-intercept is going to be 0, 1. Okay, so the next thing I want to do is to find my vertical asymptotes. And again, my vertical asymptotes are going to be when my denominator is equal to 0. And so I could look right here with my factored denominator and set those factors equal to 0. And so I'm going to have x plus 2 is equal to 0 and x minus 2 is equal to 0. So x is going to be -2 and x is going to be +2. So I have vertical asymptotes at x equals 2 and x equals -2. To look at the horizontal intercept, again, I look at the degree of the leading terms in the numerator and the denominator, and here I have they're both to the second degree. And so now this one's 3x squared and this one's x squared. So actually my numerator is going to be growing 3 times as fast as my denominator. So if I graph this function, I can go ahead and graph it, and if I go ahead and graph it, let's go ahead and confirm what we have found. It does look like I have a vertical asymptote at x equals -2, also at x equals 2. It looks like I'm crossing the horizontal axis at -3 and also at 4, and then also crossing the vertical axis at 1. So here, if we look and say, well, what about a horizontal intercept or horizontal asymptote? Let's look at our table. Maybe go to table setup and start at 1, but let's go up pretty quickly. Let's go up by increments of 200 and look at the table and see what it's doing. And I can see that my values are getting pretty close to 3. And so if I look back at the equation here, I can see that it's getting that my numerator is 3 times as much as my denominator. And actually that is how we determine the horizontal asymptote. Okay, so here's our rule for horizontal asymptotes. If the degree in the numerator is less than the degree in the denominator, the horizontal asymptote is y equals 0. If the degree in the numerator and the degree in the denominator are the same, the horizontal asymptote is going to be the ratio of the leading coefficients. So here, since the degree is the same, my horizontal asymptote is going to be the ratio of my coefficients, which is 3 over 1. So I have a horizontal asymptote at y equals 3 for this function. Okay, so for the videos that you've been given, hopefully that you will be able to go through and determine how to find the x-intercepts, how to find the y-intercepts, how to find the vertical asymptotes, how to find the horizontal asymptotes, and how to determine if there's a hole in the graph. Kind of a lot to do for these rational functions, but if you get a little practice, you'll do just fine.